Hey Natalie, real quick video on trigonometry. So the most important thing to understand is that trigonometry is just studying the ratios that we can create within a right triangle. At least that's where it starts. It can expand from there, but that's the basic premise. You always, when you're talking about the trig ratios, you always have to have a reference as far as what angle you're talking about. Now the reason you want this is like, let's say that we're talking about the 60-degree angle right here. If we're talking about the 60-degree angle, you'll notice that the opposite side to the 60 is square root of 3, right? Now, if I just said, what's the opposite side? What's the opposite leg? You wouldn't know if I was talking about the 1 or the square root of 3 because those two right there, are both the legs. So you have to know, like, oh, he's talking about the 60-degree angle. So the opposite of the 60-degree angle is square root of 3. But if I said, what's the opposite of the 30-degree angle? You would say, oh, that's the 1. So you always want to have an angle to reference that. Now, how does that look in a problem? Well, let's take a look at it. You'd want to know what trig ratio you're looking for. What ratio are you trying to use? What sides are you trying to talk about? So we would say the sine of some angle, the sine of, let's say, 30 degrees. Now, the sine of 30 degrees is just saying, okay, so I'm going to focus in on the 30-degree angle here, and then I'm going to use SOH CAH TOA. So that's going to be the opposite leg over the hypotenuse. So we write down the opposite over the hypotenuse. Now, I like to say opposite leg because it just emphasizes that it's the leg you're talking about. So when you look at this, you're like, okay, so what's the opposite leg to the 30? What's the opposite to the 30? So we're looking, oh, opposite to 30 is 1. So we're going to say that this is 1. And then what's the hypotenuse? Well, the hypotenuse is the entire side opposite to the 90-degree angle. So this right here is going to be 2. And this is where we come up with that the sine of 30 is equal to 1 over 2. Now, the reason you want to have an angle is also because the sine of 30 and the sine of 60 aren't necessarily the same, right? So I know that sine is opposite over hypotenuse. That does not mean that the sine of any angle, right, let's say 30 degrees, is equal to the sine of any other angle, the sine of, let's say, 60 degrees. This actually is false. This is something that doesn't work. And the reason is because the opposite to the 30, which is 1, is not the same as the opposite to the 60, which is square root of 3. And that's why those two things are not the same. Now, one of the things that was being discussed in Khan Academy, so Sal's video, is that, that he was using theta. Theta is just another angle. Let me break that down for you. So let's erase this, right? And instead, let's just go abstract. What I mean by that is let's just look at what happens if we named the pieces without thinking about, right? If we name the pieces without thinking about numbers and actual angles. First thing we have to establish is that we have a 90-degree triangle. So we'd want to make sure that we have a 90-degree triangle, which we have here, and then we'll just name some things. So I'm going to call this over here N for Natalie, and then we'll go P for Paloma, and then we'll go A over here at the 90-degree angle, so we got nap time. And then let's talk about the sides. So the side over here on the left, we're going to call this side L, and the side on the right, we're going to call this side M, and the side at the bottom, we're going to just call that side H. All right. You'll notice I use different type of font for the sides and the angles so that we can figure out the differences between those things. All right. And then now all that Khan would be doing is like, if he called this theta right here, that's just another thing. You could pretty much call it anything. You're like, oh yeah, I want to call it the omega right there. Fine, call it the omega. And you're like, but I want to use like some Japanese lettering. Then you can call it, oh, sorry, that's not Japanese. That's Greek right there. That's pi. Oh yeah, you call it pi. You call it whatever you want. You're like, oh yeah, I want to call it the dude chilling on the corner, right? The dude chilling on the, you can call it anything. It's just Khan happened to call it theta. Okay, theta is just another type of letter. We're going to call it n. So if I said, okay, so find the cosine of n. Find the cosine of n. Well, then you'd be like, all right, cosine is the adjacent over the hypotenuse. So then I'm thinking to myself, okay, so I need to find the adjacent. So we're focusing on n. This is my focus. So we're focusing on this angle here. Well, what's adjacent? What's the adjacent leg? So to determine what's the adjacent leg, the first thing we're going to want to do is we're going to go, okay, so this is a leg and this is a leg, right? So L is a leg and M is a leg. But the adjacent leg is L, because that's the one that's right next to angle N. So that's what I'm going to focus on. I'm going to be like, all right, so cosine of N is leg L, right? The adjacent leg L over the hypotenuse. Now the hypotenuse in this problem is over here, right? The hypotenuse is over here. So we'd say L over H. So it gives us the opportunity to look at trigonometry through the lens of any potential angle. In our class right now, all we're focusing on is sine, cosine, and tangent of very specific angles, the 30-degree angle, the 45-degree angle, and the 60-degree angle. If you have any other questions, hit me up, let me know if I can expand on this for you.